All right, if you're a Java developer, you know this feeling. Writing concurrent code can feel like you're on a high-wire act. It's super powerful, sure, but one tiny misstep and the whole thing just comes crashing down. But what if I told you that entire act is about to be replaced with like a solid, safe bridge? Today, we're digging into Project Loom and how it's about to completely revolutionize concurrency in Java.
So, let's just kick things off with a big question, right? The one that's on everyone's mind. Why is this stuff so ridiculously hard? I mean, it's a pain we've all felt. Wrestling with these limited resources, trying to hunt down impossible-to-find race conditions, and just staring at code that spirals into this unreadable mess. This is the exact problem that Project Loom was born to fix.
Okay, so the old way, the problem really comes down to three things. First off, a traditional Java thread is basically just a thin disguise for a super expensive operating system thread. They just gobble up memory, which means you can only have a handful of them running at once. So to get around that, we came up with thread pools. Smart, right? But then, when a task in that pool gets blocked, waiting for a database or some network call, that expensive OS thread just sits there, doing nothing. Totally wasted. And finally, to fix that problem, we all dove into these really complex asynchronous patterns, which, let's be honest, usually ends in what we all lovingly call callback hell, code that is just a nightmare to read, let alone debug.
All right, so how do we get out of this mess? Well, the first and honestly the most fundamental part of the solution is something called a virtual thread. This is where virtual threads come in, and trust me, they completely change the game.
And this right here, this shows you just how different the thinking is. On the one hand, you've got your classic platform thread. It's this heavyweight beast managed by the OS, and it has a huge memory footprint. Think of it like a semi-truck. Incredibly powerful, but you can only really afford a few of them on the road. Then you've got the new kid on the block, the virtual thread. It is unbelievably lightweight, managed entirely by the Java virtual machine, and has a teeny tiny memory footprint. This is your fleet of delivery drones. You can launch millions of them, and it's cheap and super efficient.
And if that last slide didn't convince you, just look at this chart. This really puts it in perspective. If you try to fire up 100,000 of those old platform threads, your app is almost certainly going to crash and burn with an out-of-memory error after it's eaten through 100 gigs of RAM. But with virtual threads, you can spin up that same 100,000 threads and way more using only about 1 gigabyte of memory. We're not talking about a small improvement here. This is a total game changer for what's even possible.
So you're probably asking, how is that even possible? Well, the magic is all in this clever idea of mounting and unmounting. It works like this. A virtual thread needs a real platform thread to actually run its code. Think of it as a carrier. So the virtual thread gets mounted on the carrier and starts running. But, and here's the brilliant part, the very instant that virtual thread has to wait for something, like a network call, the JVM unmounts it. It saves its state off to the side, and that carrier thread is instantly free to pick up a different virtual thread and start running its code. It means those expensive OS threads are kept busy almost all the time. No more wasted resources. It's that simple.
Okay, so problem one is solved. We've got millions of threads. Awesome. But, that creates a whole new problem, right? How in the world do you manage millions of anything without it turning into total chaos? That's where the second big idea from Project Loom comes in. Structured concurrency.
For the longest time, concurrency in Java has been, well, a bit of a free-for-all. We just fire and forget these tasks into some executor, and the parent thread that launched them has basically no control. It's a recipe for resource leaks and makes handling errors incredibly painful. Structured concurrency just flips that whole idea on its head. Now, your tasks are all neatly grouped inside a clear scope. The parent and its child tasks, they all share the same lifetime. So when that parent scope ends, you are guaranteed that all the child tasks are finished or canceled. It's clean, it's reliable, and it makes leaks pretty much impossible by design. The Project Loom team themselves came up with the absolute perfect analogy for this. They said, structured concurrency is to concurrency what structured programming, like your if for blocks, is to GoTo. It's all about taming that wild, anything-can-happen vibe of old-school concurrency and giving it the same kind of order and sanity that we've had in our normal, single-threaded code for decades. So, what does this actually look like when you're writing code? You might be surprised. It's actually incredibly simple. You just create something called a structured task scope, and you'll usually do this in a try with resources block, so the cleanup is automatic. Then inside that scope, you just fork as many subtasks as you need. They all start running concurrently. Then your main thread calls join and just waits for them all to come back. The best part? The code reads from top to bottom, just like simple sequential code. But behind the curtain, all that work is happening in parallel, and all the messy management is just handled for you. It's beautiful.
Okay, so let's recap. We have tons of cheap threads. We have a neat, tidy way to manage them. So what's the last piece of the puzzle? Well, it's all about sharing data. How do we pass information around safely and efficiently in this new world with millions of threads?
Now, the old way to do this was something called thread local, and honestly, it's just not cut out for this new world of virtual threads. It has some major issues. First, its values can be changed by anyone, anywhere, which can lead to some really nasty, hard-to-find bugs. Second, they're famous, or maybe infamous, for causing memory leaks if you forget to manually clean them up. And finally, passing them down to child threads is super inefficient, a total non-starter when you might be creating thousands of threads a second.
And the modern solution? It's called the scoped value. And as you can see, it was tailor-made to fix every single one of thread local's problems. Instead of being mutable, scoped values are immutable. You can't change them. Instead of manual cleanup, their life cycle is tied to their scope, so cleanup is automatic. Bye-bye memory leaks. And instead of those expensive copies, they are passed down to child threads super efficiently. It's simply the right tool for the modern job.
All right, let's bring this all home. We've got our lightweight virtual threads from massive scale. We have structured concurrency to manage the chaos, and we have scoped values to share data safely. What does this actually mean for you, the developer, when you sit down to write code tomorrow?
It means this. And this is the most important takeaway of the whole thing. For years, we have been forced to twist our code into these unnatural, complicated, asynchronous shapes, all just to work around the limitations of old-school threads. Project Loom says, forget all that. We finally get to go back to writing code that just makes sense. Simple, top-to-bottom, blocking code that you can actually read and understand without a PhD in concurrency. You just write the simple, readable code and let the virtual threads handle all the heavy lifting and scaling behind the scenes.
And all this simplicity leads us to one final, pretty provocative thought. The whole world of reactive programming, frameworks like ArcsJava and Project Reactor, it all became popular to solve the exact scalability problems that we've just been talking about. So now that these problems are being solved directly inside the JVM with virtual threads, is the reign of these super complex reactive frameworks over? It's definitely something to think about, as the future of concurrency in Java looks simpler and clearer than it has in a very long time. Thanks for tuning in.